Hello YouTube, RJ. Hey, got a bunch of stuff in. Got half of the stuff that's been jammed up in customs for like 3 weeks from AliExpress. It's been hanging me up on the Lynx EZSW receiver getting that project complete. I'm sorry about that, but can't do things when I don't have parts. But I got some of them in today. We're going to see which ones I got. Still waiting on another package with the rest. Got some other things in. Just quickly going to go through that. And then what I want to show you is I've been working on some software for the lab. If you watched my video on my GPS-DO, you remember I was having a little discrepancy in what was reading on the frequency counter and what was reading on my little Python script that I record. I want to fill you in on some of that, show you what I found, and show you what I did. I created some new software that I think you're going to like. So we'll get to that at the end of the video. So let's take a look at what we got. I've already opened this because there was a couple things in it and I got some cables. These particular cables are BNC to SMA. And the reason I got these were to hook up what I'm fixing to open up in just a moment. And I'll explain what I'm fixing to open up, and I'll explain why I had to get this. It's all right, don't need the bag anyway. So anyway, this particular, I picked these up to connect up for the GPS-DO. So we'll come back to that in a minute. Let's go ahead and open up. Well, I won't open this, but I'll tell you about it. This is from Easy Screen Print. This is the screen printing material I use. I had some smaller units. It turned out they weren't quite big enough to do what I wanted to do with them. So I ordered some, I had these and I'd ran out some 8.5 by 11 full sheets of the screen printing screen so I can do some artwork. And that artwork is for the EZSW receiver. I have decided to go ahead with my little blue case, the little metal plates, and I'm going to go ahead and screen print. Now, I can't screen print everybody's boxes, so that's not a solution for everybody. But you know, you can do labels. There's a whole bunch of ways to label your projects, and you know, maybe you have your favorite way. I got a lot of feedback that said people were interested in doing their own boxes, and maybe they want to do something different, and some would do whatever I did. And so it came to my realization is I just can't try to plan out everything for everybody on the project because they're going to want to go their own way anyway. I'm going to go ahead and use this little blue box. I'm going to give you all the data I use for layout and where to drill and even the artwork if you want to do screen printing. Then I'm going to leave it up to you. You do whatever you want. I'll give you all the information to do what I did and duplicate it, but I'll leave it up to you to do. And I think that's going to be a better way to handle it. Let you get your own case, buy what I use, do something else, however you want to do it. So anyway, I needed some of this. I picked it up. I'm not going to open it because it is light sensitive. We want to put that away. Here is the next little jewel that we want to talk about. I got nothing to pull. There we go. Okay. Make sure I'm not throwing anything away. Okay, what this is this is a distribution amplifier, isolated distribution amplifier. So let's pull this rascal out and take a look at it. And what this is about, it's a little jewel, runs on USB, this is for, well, you can use it for a number of things, but what I'm going to use it for is it's an isolation distribution amplifier. It's basically a little transformer in here that has an input for RF signals. It isolates the input from the outputs, and then it has little operational amplifiers that provide whatever's coming in here. It pretty well keeps it unity. And what I'm going to use it for is to take my GPS-DO signal and split it out to multiple instruments. Now, in the video with the GPS-DO, you may remember I said that there is such a thing in my Rigol spectrum analyzer where I can take a 10 megahertz signal in reference and it'll give me an out that's isolated. And I was going to run that back and run my frequency counter. Well, it turns out that works just great as long as you turn on the spectrum analyzer. If it's not powered up, it doesn't function. It shuts off the signal output. That wasn't practical. I don't want to always have to run my spectrum analyzer when I use my signal generator or my frequency counter. So for that reason, I just opted to go ahead. This wasn't expensive. I got it off of Amazon. I'll put a link in the video. It was like 27 bucks for this. So it wasn't a big amount of money. You got a little on-off switch here. It's got a battery. Notice it came on. It's got a battery in it. So really, this thing can run for quite a while on its own, but my intention is to plug it in and keep it powered off my USB distribution on the bench here, keep it powered up all the time. So that's what that's for, and that's where these cables come in, because my 10 megahertz into my instruments are all BNC, but as you can see, the back of this is SMA. So these two cables are going to let me distribute to both of those instruments. So that's what that's about. Neat little toy. And we'll give it a try a little later on. I don't know that I'll do that in the video. I'll get it all wired up, and I'll let you know how that come out in a future video. I'll just bring it up and let you know how that came out. Now let's open up and see what we got from my buddies at AliExpress, because I have no idea what's exactly what I got. I know I didn't get everything. So I got a few items, but I didn't get everything. So let's find out what I did get. Should be stuff for the radio. Okay, it is. Here's some knobs. Looking for knobs that make me happy to use in the kit, that I can get quantity at a reasonable price. So we'll try those out, so I can have a more consistent knobs on the front. Would be nice. Otherwise, everything comes with their own knobs, and they all look different, and they don't, not even like, you know, not even, and they don't even look like each other. So I want to, okay, here's something I've been waiting for that will help. This is a 3.5 audio jack. This is going to be for your headset coming out the back. So I needed those. One of the things I'm waiting on is the 4-pin sockets to build the new antenna tuner. And I'll show you how all that comes out when I get everything here. These are standoffs. These are nylon standoffs. These are what I'm going to use to hold the board, physically mount the board in the radio. So we got some stuff that's going to help. Now if I can just get those 4-pin sockets, and what it all boils down to is we've got new boards for the antenna tuner. This is my new design to save space. If you watched the video where I talked about shrinking it, you'll know what I'm talking about. Look at the static on that plastic, won't get off me. So anyway, what you got is you're going to have this board. You're going to put the toroid on the back of it like this. You're going to have your print where you can easily see. This is solder. What I do is stick some solder through there, hold it up to give you room to get your wire through until I get a few turns on there. But you're going to wind this. You're going to put your pins on here, your 4 pins, and then you're going to have on this board, you're going to have sockets. So what will happen is the switch will go on here, the Varicaps will go in here, and this will plug in to this board like this. And that way we got rid of some physical 2D dimension of the front panel, so we can fit this on the front panel well. And we just went a little deeper by moving the toroid behind it. So it's sort of like the original where you kind of looped wire and twisted and connected to the pin directly and stuff, but you don't melt the switch and you don't have the problems of trying to get those windings. It was just very difficult. This will be a lot easier. This will build just like the one I did before that everybody seemed to like. The only difference is it's not on down here on this board down here, making the board real wide. It's on the back to take up 3D dimension, which we have plenty of. And so when we're done, this little board's going to look something like this and go on the front panel. So that's what's going on there. So with that, now let's talk about some mistakes I made in the video about the GPS DO. Okay, let me move this stuff all over here out of the way. Okay, here's my little oven controlled 10 megahertz oscillator that we've been using to drive the signal generator for a while. And I got the new GPS DO hooked up, and we were taking a look at this to see how accurate it was. And it was coming up 10 megahertz on the money on my meter, on my frequency counter, Siglent 1032X. But I was recording on my little Python script that shows the frequency, and it was reading 99999. It was reading 1 hertz low. And I said, I've got to look into that because they're not matching. I see 10 megahertz precisely here, you see 1 hertz low. So I went and researched that since that video was done, and what I found was there was nothing really wrong. I said, maybe it's got to be a rounding issue. Well, it kind of was a rounding issue, but not really the way I was thinking. I had kind of lost track of something, and that is that on the frequency counter with Siglent, my Siglent here, when you hit, I cannot get that off of me. Sorry, it's driving me crazy. got static. There, I got it. On my 1032X, when you're reading the frequency counter, it has the 10th position. It has a decimal and a number. The last digits are dot something, decimal something. And I'm used to that. I kind of knew this back in my head. When you hit 10 megahertz or higher, that goes away. It no longer provides that to you. Once you add that additional digit on the front, it drops the decimal point off the back. So this led to two incorrect things that happened in the video I want to correct. When I was looking at it, what was happening is it turns out that when you read the data from the Siglent counter via Skippy, it gives you 2 decimal places accuracy, which it does not display. It actually has that in the meter, but it doesn't give it on the display. So I get a much more fine resolution on Skippy. And what was happening is it turned out in my script, I was only showing the integer. I wasn't showing any decimal places. In reality, what it turned out to is this was running 9999999.97. It was 0.03 of a hertz below 10 megahertz. So the display on the Python was dropping the 0.97 in formatting and just showing the 9999999. This actual Siglent meter was rounding and showing 10 megahertz, so which makes total sense. So that's where that came from. But while I was in looking at the code, I decided I could do so much better with the little virtual instrument readings where I can put it up. The little program I use, the little Python scripts I've been using to show the frequency counter and to show my meter, where I could pop them up on screen and you could see what the readings are without having to set up cameras and point at them. That way it's clear and it's easy to read. I realized I could do so much better because I wanted to change the font to make it more readable and colors and stuff. And in Python, through a console like that, I can't do that through the normal terminal. So I just decided to take a moment and say, the heck with this, let's start over and write little virtual instruments that are virtual displays of my instruments. And I broke down and went in and wrote it in C# as a window app where I could use different fonts, different colors. I could make it kind of anything I want to do with it. It's going to work very, very well. Very happy where it's going. I'm going to make some additional. I'm going to do one for my power supply also. What I want to do is while this is hooked up, I'm going to go ahead and get my signal generator fired up here so we can go to the frequency counter. I'm going to show you that. Give me a minute and get that all set up. I'll get on the computer, bring these up and show you what they look like. Okay, here we are on the computer, and I've got 2 of my little virtual instruments up here. And when I video, I can just screen capture these windows and then I can overlay them to show you what I'm seeing while I'm working. Here's the multimeter. And when you bring them up, they don't automatically connect because your meter may not be on. So I bring them up and then I have the ability to connect and disconnect as needed. And I can launch, if I'm going to just do the meter, I don't launch this one. I just bring up the meter. And if I'm going to do both, I bring up both. And you can be running all of them. I'm going to create one for my O1 power supply and maybe some other stuff. But for example, if I'm going to do a video, I'm going to be using the multimeter on the bench, and I want you to be able to see the voltages without having to have a dedicated camera at that meter. I can just come up and connect to it. And right now the probes are just laying on the bench. So you see that it's connected and it's updating. That way, when you don't have a changing value, I know the program's functional and it's updating. There's just no voltage. Let me go over here. I'll pause a second. I'll go over and turn some voltage on. I'll turn the power supply, plug the power supply into the meter and turn some voltage on so that we can see it reading. Be right back. Okay, so I've turned the power supply on and set it for 5.1 volts, and you can see that it's pretty close. Power supply is doing a pretty good job. It's got that high impedance meter hooked directly to it without anything loading it, so I'm surprised it can regulate that well. But you can see it. It's telling me that the meter's on 5 volts. If I change range, this updates to show. If I change to amps, this will come up and say amp DC, amp AC, milliamps. So it'll follow the meter. Whatever the meter is doing, it'll follow here. You can clearly see what the meter is doing as I'm working with it. Then we have the Siglent SDG1032X, my signal generator frequency counter. And if I go ahead and connect it, you see it immediately pops up and we've got our frequency counter, what it's reading. And so my little oscillator that we've been using to calibrate is 99999.93. So you can see that with my Python script, if I drop the decimal 93, this is the reading we get. See, it just bounced to 10. So now we're exactly. So I mean, that's how close this thing is. Look at the ppms. So you have the frequency here that it's reading, and then you have the reference frequency, what I've dialed in on the meter to say this is what I want. And using that, then it can calculate a deviation for me and tell me how many parts per million I'm out. So that's what was going on with that. I've got it showing me the duty cycle. And then down here, as I said, I've got the reference and then the deviation from this frequency to my reference. Then I have the signal generator output. I've got the two channels and what frequency they're set to and whether they're on or off. See, I turned one of them on, left the other off to show you that it indicates when you're on or off. That's what these little virtual instruments. Now, let's talk about the big boo-boo I made. While I was looking at this, I was like, wow, this thing's great. Everything's wonderful. Let's check the internal reference of my signal generator and see how accurate it is on the internal reference. And then I went on to tell you some incorrect stuff. I got all confused and got off. And again, I'll explain why. Just let me go switch my signal generator to the internal reference so we can see this, and I'll talk about it. Give me just a second. Okay, now here's what I did. In the previous video, I looked at this and it was like 73, I think, before. And I looked up and I said, hey, it's 7.3 hertz off, and I was incorrect. And here's why. Again, I had forgot that this drops the decimal plate on the screen of the signal generator counter. It drops the decimal point. Usually I have 1 decimal point. So I just glanced up and saw, you know, kind of, remember I was farther away from the screen than you guys. I looked up and I saw 7.3, I think it was in the video. I saw 7.3 and thought it was 7.3, and that's where I came up with that. In reality, I was 73 hertz off. As you can see, that's in the ballpark. So I was actually 73 hertz off. Now, does that mean that my frequency counter was off? No, because I carried that boo-boo on and continued to think wrong. And what it comes down to is, if you remember, Siglent says that up to a year, they guarantee it'll be within 25 parts per million. Well, 25 parts per million at 10 megahertz is 250 hertz. So I'm well below that. In fact, we get the direct ppm readout here. I'm 6.7 ppm when I'm allowed 25. So yes, I'm about 25% to the calibrated reference guarantee. So my Siglent's doing quite well at 6.6 ppm. I think that's very, very good. So anyway, I'm sorry about those confusing facts. Again, I misread it. Now with this, you'll always see 2 decimal points with this. No matter what frequency I'm at, the signal generator actually reads down to the hundredths of a hertz. And through the CFP, I get that, so I can actually show it on this. So in a way, this actually is a little bit better of a setup than looking at the screen of the meter itself, which is kind of sad to say. But so anyway, this is something I worked on, and like I said, I'm going to create one for the power supply, so I can bring up my O1 power supply and show you on screen what's going on with it, what voltages I have it on, when it's off. So I hope this is interesting. Hope you enjoyed this. I'll get right back to getting this little radio receiver finished as soon as I can get the last of the parts in. I can go ahead and get all this done. I'm going to be working on drilling the front panel and silk screening it, and which I can do that. I'm going to work on that. Thanks for hanging out with me on this one. Hope you saw something that you were interested with. If you did, hit the like button for me. And if you're not subscribed, do me a favor, hit the subscribe button so that you catch my videos in the future. And most of all, I want to see you in the next video.